sketch the graph of y equal to x minus 2 to the power of 4 minus 1. This is a quartic graph, and we're now sketching it using transformations. The transformations formula looks very similar to what you saw for the cubic graph and also for the quadratic graph, except the power is now a power of 4. And if you know the general shape of the y to the power of equals x to the power of 4 graph, which is just like similar to a quadratic shape, all you have to know is if there's a negative in front of the bracket, then it turns into a reflected graph. So reflected in the x-axis, it might look like this. If there is a coefficient in front of the bracket, that's a dilation factor, and we can stretch to and from the x-axis, so it might get wider or narrower overall. If there is a h inside the bracket with the x, that is a horizontal translation in the x direction, so left and right, and we have to be careful to swap the sign when we're actually figuring out the coordinate of the translation. And finally, if there's a k which is outside the bracket, then that's a vertical translation in the y direction up and down. Importantly, with all these pieces of information, we can really just get these h and k and transform them into the turning point. And I would really recommend that being your first step to doing any sketch of a quartic, because it's a great base to go from. And then after that, you might want to just find some of your axes intercepts, like x and y axes, and just double check if it's reflected or not, and then I think you're pretty much good to finish the sketch from there. So let's give this a go on our own now. We have this graph y equal to x minus 2 to the power of 4 minus 1. So if I compare it to the form, what I just had, which was x minus h to the power of 4 plus k, I can see that h comma k, which corresponds to the turning point, is equal to 2 minus 1. You can see that the minus has to stay in the form, so we've essentially taken this and swapped the sign to get it as part of the turning point coordinate. So let's go and draw roughly what that is, so I can have 2 and minus 1. So my turning point might be here, 2 comma minus 1. Now I know that because my graph is positive, there's a positive sign, that it will be like a happy face, like a positive quadratic, similar to a quadratic, so it will be up facing. So I know that it will look something like this. But before I draw it, I'm going to find out some intercepts to make it a bit easier to draw as well. So to get my x-intercepts, I'm going to let y equal to 0. So I have this problem here, which I just need to solve for x. So I'll move the 1 to the other side, giving me positive 1 equal to x minus 2 to the power of 4. Now when I take the fourth root, I need to also put the plus or minus. So I take the fourth root of 1, leaving me to get rid of that power. And I really have to remember the plus or minus. So this splits off to give me two solutions. I end up with one being the positive 1 equal to x minus 2, and the other one being the minus 1 equal to x minus 2. Now I can just add 2 to both sides. So when I add 2, I have 3 equal to x. So this coordinate is 3, 0. And when I add 2 to this one, I get 1 equal to x. So this coordinate is equal to 1, 0. All right, so really, really important. You would be missing a whole coordinate if you forget to do the plus or minus. This is such an easy thing to forget to do. So really, really ingrained that you need to do that, okay? So I have the 1, 0 coordinate, that's here, 1, 0. And then maybe here I have, over here I have 3, 0. So now I can maybe find my y-axis intercept, so I'll do this here. So I'll let x equal to 0, y equal to, I have 0 minus 2 to the power of 4 minus 1. So that's actually equal to positive 16 minus 1, so 15. So my y-axis intercept is 0, 15, which is quite high. I'll put it maybe somewhere right at the top, 0, 15. And now if I connect my dots, I'll get the general shape of my quartic looking like this. and I'll label it as y equals to x minus 2 to the power of 4 minus 1. I have my x-axis and my y-axis to label, and I've got my axes, intercepts, and my turning point all labeled, so that should be a fully completed graph of my first translated quartic.